All right, you guys, we are now doing yet again another proof involving angle properties. And these are going to be slightly different than the angle properties we just did. So get excited. Something new, something exciting. Okay, so I am given that angle 1 and angle 3 are vertical angles. So I know that these two are vertical angles, and we're trying to prove that the vertical angles are congruent. So if you look through your nifty note sheet, what theorem are we proving? Correct, you guys. We are proving the vertical angle theorem. So, since we are proving the vertical angle theorem, you are not allowed to use the vertical angle theorem in your proof anywhere. Okay, so basically, someone was like, oh, I know that vertical angles are congruent. And someone was like, well, prove it to me. So they had to show using things other than the vertical angles to show that they are congruent. Just like it just makes your argument much better if you can use other resources and pull those in to prove what you're trying to say. So basically, we can't use the vertical angle theorem since that's what we're proving. We have to use some of our other theorems, angles, definitions, and postulates to get us to the correct answer. All right, you guys, well, let's get started. What do we always write first? We do write the given first. You guys always know what to do. All right, so my given is angle 1 and angle 3 are vertical angles. Angle 1 and angle 3 are vertical angles. And that was just simply given to me on a nice fancy golden plate. So this is just the given. Nice, you guys. All right, so I have to show that 1 and 3 are somehow congruent. I can't use vertical angles, so that's out. But if you guys see here, I have this nifty 2 that's kind of hanging out in the problem. Maybe if I could show that angle 1 and 3 are somehow related to angle 2 in the same way, maybe then I could show that 1 and 3 are congruent. So let's see here. If I look at angle 1 and 2, what do they form when you put them together? Do you guys see it? Whoa, do we see it? Cool. All right, so angle 1 and 2, when you put those bad boys together, they make this pretty line. Okay, which means they form a linear pair. All right, same if we look at angle 2 and 3, what do those bad boys form when you put them together? Yes, you guys are correct. Heavenly hamburger. Okay, so 2 and 3 will also form a line, which means 2 and 3 also form a linear pair, which if you look at your definition of a linear pair, what that states is that they are also supplementary. So I'm going to go ahead and state that angle 1 and 2, as well as angle 2 and 3, form a linear pair and are supplementary. And the reason why I know that is by my definition of a linear pair. Okay, so angle 1 and angle 2, as well as, I'm going to put a slash, angle 1 and 2 and angle 2 and angle 3 form a linear pair. Hopefully I have enough room, I don't know. And are supplementary, which I think I'm going to run out of space. But this word says supplementary. Sorry, you guys. I did not calculate my space very wisely. I apologize in advance. Okay, so angle 1 and 2, as well as angle 2 and 3, form a linear pair and are supplementary. And the reason why I know that is by my definition of a linear pair. Definition of a linear pair. Definition of a linear pair, which I'm going to refocus because it looks like things are out of wacky. Okay. They're all right. So anyways, man, I shouldn't have zoomed in. Sorry, guys. I kind of messed it up. All right, that looks a little better. So anyways, now I need to keep going, which remember, it's helpful if you can grab things either from the given, and since we can't grab anything from the given, also from previous lines, if you spot any words that might be helpful, that might be a good route to go to figure out what to write next. So do you guys spot anything in this line that could be helpful in writing something else and getting us closer to showing that 1 and 3 are congruent? I see it too, you guys. Oh man. Do you guys spot the word supplementary? What does it mean for two angles to be supplementary? It does mean that they add up to be 180. So since I know 1 and 2 as well as 2 and 3 are supplementary, I can add those bad boys together and set them equal to 180. So I can say the measure of angle 1 plus the measure of angle 2 equals 180. Okay, I can also say the measure of angle 2 plus the measure of angle 3 also add up to be 180. And that is because that's what it means to be supplementary. So definition of supplementary. Definition of supplementary. All right, you guys, we're moving along. Okay, so again, I'm trying to show something about 1 and 3 being congruent. So I'm getting closer. Do you guys see anything in this line that might get me a step closer to showing that 1 and 3 are congruent? Well, do you guys see that both of these statements right here, both of these statements equal the same thing? They both equal 180. So if they both equal the same thing, doesn't that mean they equal each other? Yes, it does. So my next step, I can say that the measure of angle 1 plus the measure of angle 2 will equal the measure of angle 2 plus the measure of angle 3 because they both equal the same thing. Also, since they both equal 180, I could technically replace this 180 with this statement and just slide this statement right beside measure of angle 1 and 2. Okay, so since I'm kind of replacing something with what it equals, what is it called when we replace things with what they equal? Correctamundo, it would be by our substitution property. Sorry, I had a moment there. Substitution property. Now this one, you guys, you could also use the transitive property because you could say if 1 plus 2 equals 180 and 180 equals 2 plus 3, then 1 plus 2 equals 2 plus 3. So it's also kind of the transitive property. It's got that transitive flow that we're looking for. So you could also say transitive property on that line. Nice, nice. All right, so now we're definitely getting closer. So I'm trying to show that 1 and 3 are equal, which means they are congruent. So I want to show that 1 and 3 are equal, but currently the measure of angle 2 is getting in the way, and it's making me so mad. I'm about to let the demon cats get me, which is really bad, so I better stop myself. Stop my song. Okay, I'm good, you guys. But anyways, I want to get rid of that angle 2 because if I can get rid of angle 2, then I will have 1 equaling 3, which is what I'm trying to do. So how could I get rid of my measure of angle 2 on both sides of my equation? What could I do with the measure of angle 2? Man, you guys need to get a math degree. You are so smart. You would subtract it on both sides of the equation. So the measure of angle 2 minus the measure of angle 2 will cancel and turn to 0. The measure of angle 2 minus the measure of angle 2 will also cancel and turn to 0. So I'm left with the measure of angle 1 equals the measure of angle 3. And since I subtracted the measure of angle 2 on both sides of my equation, that means that I use the subtraction property. All right, you guys, so I've shown that the measure of angle 1 equals the measure of angle 3, and I'm trying to prove that that means that the angles are congruent. Well, if the measures are equal, that means that they have to be congruent, because what it means for two angles to be congruent is that their angles are equal, their measures. Okay, so now I can safely assume that 1 is congruent to 3. Yay. So I can now show that. And the reason why, what is it called when you transform an equal sign into a congruent sign, or vice versa? What is it called when we do that? It is called definition of congruence. And also, guys, that's what it means to be congruent. So, yeah. So, definition of congruence. And I'm sorry, guys, I messed up my color pattern, but it's okay. It'll be all right. All right, well, wasn't that exciting, you guys? It just gets more fun the more proofs that we do. Way to go, you guys. That was a blast.